What did we do yesterday? Normalization. That was an important topic we discussed. I had given you one task, right? And the task was to do what? Research. That means I can do some quiz, right? Let's use AI to generate the quiz. Although I have the quiz, but I just got an idea. ChatGPT and create set of quiz questions. Remember, I had given you some reading material. Ready for the quiz? All right. I will ask specific people to answer the questions, okay? कितना क्वेश्चन बना रहा है? Okay, first question. What is the primary goal of normalization in database design? Let's start with Chaitra. What do you think? The first
So normalization is used to divide the complex table into small tables.
Okay, anybody would like to improve on that answer? Anybody? Abhijit, do you want to improve on Chaitra's answer?
Sure, sir. Normalization basically refers to, as Chaitras told, it is basically dividing a complex table into smaller tables in order to manage or reduce the uh, like anomalies which happen. For example, if there is a huge table which consists of, let's say in a bank, there is a loan procedure going on. So there will be different tables in a bank regarding customers information, then their own employees information, as well as information on the basis of related to loans and other things. Secondly, while
ठीक है, ठीक
using
है,
the
ठीक है, अभिजीत, ठीक है, ठीक है. Kamal Laksha has put it very nicely. She said, or he said, to reduce data redundancy and dependency, leading to a more consistent and reliable database.
yes, sir, I was coming to that only, but little slower.
Yeah. So essentially to reduce redundancy by dividing the database into multiple category-based tables. And those category-based tables are called as entities or tables. Understood, everybody? Clear? Huh. If you did the research well, then you should be able to answer this question. Describe the concept of first normal form. How about you, sir? What's your name? Subroto. What's what? So, but how will you? We have, I don't know how many classes have we had? 4. No.
Classes. Last 2 classes. Last week.
Boss, we have had 6 classes, man.
Yes.
So you have missed 4 classes. Dada,
I have seen your video and
then you must answer.
so this video I just came back today and I just connected.
Chalo. Haji, what's the cake lady? Yeah, girl. Tell me, what's your name? Ikshita, tell me. नहीं पढ़ा? Your friends? Give me an example. नहीं पढ़ाई किया, पढ़ा लेकिन समझ में नहीं आया क्या? जूही, जूही, जूही.
Yes, sir.
Good
afternoon. Yeah.
Describe
Yeah,
the first name. Yeah.
Should I describe 1NF, sir?
Yeah.
Okay. So it's basically in 1NF, data is organized into tables with rows and columns. And each cell contains the single atomic indivisible value. Every column in the table contains has a unique value, unique element, and each table is identified by unique column.
आप तो पढ़ के बोल रहे हो लग रहा है जूही क्या?
Yeah, exactly, sir.
थोड़ा समझाओ फिर. Explain this to me.
Okay.
Give me an example.
Okay. So like if we have a table, a data set of students where we have ID, last name of the student, ID proof, and say grade also. And if we run a normalization, if the process of normalization runs over this data set, it segregates the data into 2 tables, like one for the students and one for the the data set I have described. It has data of students as well as professors who are teaching those students. Then this will segregate the data into students and professor IDs, like student ID and student name, and professor ID and professor name. And the last, what I have mentioned is grades of the students. Then it will segregate the data of according to grades also.
Chalo, I will. She's the right path, but I think just to summarize what she was trying to say. I mean, what first normalization form says is each table should have a primary key. It doesn't mean that every column of the table has to be unique. That's almost never. And it also doesn't mean that the table has to have only one column, as you were saying. That is also not right. A table can't have just one column. I mean, there'll hardly be any utilization of that particular table. So what this simply says is that a table should have a primary key. There should not ideally be any table in the database which doesn't have a primary key, because if a table is there without a primary key, it can have unlimited amount of duplicate values. You can keep entering the same customer information again and again and again and again if there is no primary key. Do you understand what I'm trying to say? Suppose we give you an attendance sheet, which is essentially nothing but student table. And if I tell you that go sign, will you sign in one place or will you sign in multiple places? If your name is there in multiple places, you'll sign everywhere. But that doesn't mean, right? That doesn't have any practical application. I get a point. So a table ideally, as per, if a table is designed as per the first NF, if it has to pass that first NF test, then a table should have primary key. It could be a single column primary key or it could be composite primary key as well, combination of columns as well. Okay. The second part of the first normalization form says each cell should contain a single value and not a list of values. What does it mean? Imagine you have two phone numbers. You have a dual SIM phone card. Dual SIM card phone. Now, let's say there is a customer phone number column, right? Now, as per this rule, it says don't put both the numbers in the same column, even if the customer has two phone numbers. Now, you will wonder where would the second phone number be? Well, if you have designed it, if you are the database designer, and if you foresee that a customer could have more than one phone number, then you should ideally have two columns. Phone number one, alternate phone number, or maybe phone number and then an alternate number. A lot of times online forms would have an alternate number. Do you understand what I'm trying to say? But if it does not, no, it can't go to the second row because then you're repeating the customer other columns. How can you repeat the customer's data? Because that would lead to redundancy. What if a customer has 100? The government allows a customer to, now the new rule says that a customer can have 30 SIMs, up to 30 SIMs. So there you go. I get a point.
One customer, one interrelated.
What I'm trying to say is each column that we make the column in such a way that it is the smallest logical part of the data. I'll give you another example of it. For example, you have address as a column. Instead of having address as one single column, divide address into city, state, country, pin code, landmark. Do you understand what I'm trying to say? Right? And collect single units of information. For example, city should have only one city, let's say Bangalore. Now, if a customer has two addresses, then there should be a provision made. I mean, you should have thought about it as a designer that a customer could have alternate address as well. That means city 1 and city 2, or home city and alternate city, something like that. Otherwise, don't capture that information.
The atomic values is the same, na? What are you talking about?
Atomic value basically means single value. I get a point. Atomic meaning one customer phone number meaning one phone number, not like phone numbers. I get a point. Basically, what we are trying to say is that, let's say your name. Now, a lot of people have nicknames as well. But in the first name, you will not write Pratik and you will write some nickname as well. I'll not tell you what my nickname is. Do you understand what I'm trying to tell you? I get a point. So, a column should have a single value. Got it? This would be interesting. Who would like to answer this question? Let me put it like this. How is second NF different from first NF? How is second NF different from first NF? Any suggestion, any idea?
There will be no partial dependency in second NF.
Okay, explain that with a little bit more.
Sir, actually the normalizing means dividing to a table in the small part, so that if we
Dividing the database into smaller tables, yeah.
Yes, if we take such kind of table like scoreboard, like score ID there, student ID there, and subject ID there, and marks ID there, and teachers ID there. And there will be or more tables like student table and subject table. So we can fetch the marks from the subject ID. We can fetch the marks from the student ID also, and we can fetch the marks from score ID also. But if we fetch the
Satyam,
teachers,
Satyam, I'll just take an example and explain.
okay,
If you look at the order details table here, right? Order details table is a bridge table between orders table and products table. Order details table is a bridge table between orders table and products table. And the reason why we need this bridge table or the junction table or a wire table is, if you remember yesterday, I told you that there are 3 types of relationship: one to one, one to many, and many to many. And this relationship types help you to figure out where should the foreign key be placed. Now, between orders table and products table, the type of relationship that exists is one order may have
Many products.
products. One product may be part of
Many orders.
many orders, right? So if it is one to many from both the sides, then the net relationship we call it as many to many. One to many and one to many. So it becomes many to many. If it is many to many relationship between two tables, then to create the foreign key, which will help you to create relationship between the tables, what we do is we create a third table, meaning a bridge table. And in that bridge table, what we do is we put the primary key of both the parent tables. These becomes the parent, orders and products become the parent, and we put them into the third table. But we do not create any foreign key between these two tables. That means in a many-to-many relationship, we don't create a direct relationship. Meaning we don't create a common column directly between orders table and products table. See, there is no common column. Orders table has order ID and customer ID, and product table has product ID and product name. But there is nothing like products table has an order ID or orders table has a product ID. There is no common column. Why? Because in a many-to-many relationship, we don't create a common column between or a relationship, direct relation between two many-to-many relationship related table. If you have read it correctly, then you would be able to answer this question. Why? Because it leads to massive redundancy if it did so. If we created a direct common column between the two tables, whether you create the common column, let's say if you create product ID here. Now one order may have several products. Let's say this order has 10 products. So this order ID, customer ID combination will keep repeating 10 times. So again, massive redundancy it leads to. So you will say, no, I don't want that. Similarly, if you try and create order ID here, one particular product can be part of many orders. For example, you go to a pizza house. When you order Mexican wave pizza, it can be part of several orders. Do you understand what I'm trying to say? Is that making sense? So what I'm trying to tell you is that if you don't remember anything, just remember this, that if it is a many-to-many relationship, what do we do? In order to create the foreign key, we create a third table. And in the third table, we put the primary keys of both the parent tables. That's what we have done here. Got it? And in the third table's primary key will be what? What will be the primary key of this third table?
The order ID and product ID, composite primary key.
The combination, if you notice, does not repeat, but individually these columns can have repeated values. For example, order ID also is repeating, as you can see. Product ID is also repeating, as you can see. But the combination will not repeat. That means the primary of this third table is composite primary key, which is the combination of order ID and product ID. Understood? The reason why I gave you so much of history is, now if you look at the second normalization rule, it says first the table should meet the first NI, which says the table should have a primary key. The table does have a primary key. What is the primary key of the third table? Combination, right? So it meets the first NI. Then The second NF says each non-primary key column should be fully dependent on the entire primary key and not just parts. Parts meaning, so what it is saying is each non-primary key column. What are the non-primary key columns here?
Unit price and
Unit
quantity.
price and quantity.
These are non-primary key columns. Each non-primary column should be fully dependent on the entire primary key and not just part of it. Let's ask ourselves this question. Is unit price dependent upon order ID and product ID both, or is unit price only dependent upon product ID or order ID? That means unit price is of what? Unit price is of what?
Product ID.
Product.
Product type.
Means unit price is only dependent upon product ID. It is not dependent on order as well. That means this column is not, because of this column, this table will not get the 2NF rating. Is quantity dependent upon both? Yes. In a particular order, for a particular product, there will be an X quantity. When you order on Swiggy,
No.
right? So for a particular product, let's say, you're ordering gulab jamun, 2000 pieces. So, sorry, 200 pieces, no, 20 pieces. So let's say 20 pieces is of a particular product in a particular order. So that means quantity depends upon product as well as order. Did you all understand this question at this point?
Yes, sir.
Okay, na? This is a very important thing to understand. Got it? Everybody? So quantity is fine to keep here, but not the unit price. Now, when a table does not conform, when a table does not pass the second NF rule, means that there is an issue with that table design, table design. What is the issue with this table design? If you do have unit price here, we know that product ID can repeat. Wherever the product ID will repeat, the unit price will also repeat, leading to extra redundancy. So this unit price column should ideally be in
Product
table. What is the point of having unit price in this table? If you do need it, whenever you need it, you can always join the two tables and get the unit price for this particular product at the time of query. Understood? So in order to make this third table second NF rated table, you need to remove this unit price column. Then only this table will get the second NF rating. Otherwise, this table will only get the 1 NF rating, but not the 2 NF rating. If it is not 2 NF, then it can never be 3 NF. Understood? Now let's go back to our questions. Explain the criteria for a database to be in third normal form. Let me see some Jaya. Jaya, what do you think?
So 1 second.
ChatGPT will give you answer very quickly there. But I'll ask.
I mean, so here, like we have independent data.
What?
So in 3NF, we have independent data.
Okay. Explain, Jaya, with an example.
So it's like you just gave an example of 2NF, right? So in 2NF, if we have any product ID, like here it was order ID and product ID, this was the composite primary key. Okay. So the data was somehow dependent, like that's why we removed unit price from here. So in 3NF, we don't have these dependencies.
In 3NF?
We don't have this kind of dependencies. Like here in 2NF, like when we were just, taking the order details in account, we removed unit price from here because it was just increasing the dependency. So
Okay.
we don't have that in 3NF. So that's why once the table is removed, all the dependencies will be removed.
Okay. Who can explain it again? What she did in 3NF? What's happening?
A table is said to be in a 3NF form if it is in 2NF and all non-key attributes are dependent only on primary key. So in the last example, yes, in this example, here we have three different tables for orders, products, and order details. Initially, for order details table, it cannot be in a 2NF form because of unit price. So as suggested, we can place this unit price in products table in order to make it a 2NF. Since it is 2NF right now, and if you look into the order details table, then all the quantity is basically dependent upon the primary key entirely. That is combination of order key and product ID, order ID and product ID. So by placing this unit price into the products table, we are basically making an enable of 2NF as well as 3NF because all other keys, all other elements are basically dependent on primary key.
What he's saying is, imagine we keep unit price also. Imagine for a moment, and we give quantity also for a moment. Imagine, and if we had total, now the total column would have been dependent upon price into quantity, price into quantity. These are two non-primary key columns. Total is also a non-primary column. So a non-primary key column would have been dependent on two non-primary key columns. This is something that 3NF does not like. It says this should not be, this will not be 3NF. Why will this not be 3NF? Because these are all non-primary key columns. And there is interdependency between non-primary key columns. And that's something that it does not like. So I'll give you another example. You see, you have customer's date of birth. Now, date of birth is generally not going to be the primary key column. And the very next column is age. Now, how do you determine age? It will always be dependent upon the DOB. So if you have something like that, then the 3NF says no, then we don't like it. Then that table will not get the 3NF rating. And the reason why it does not like it is, unlike Excel, which can auto-calculate total and those kind of columns, here, once the data is entered, then the data is entered. There is no like calculation that is happening in the database. When you inserted the data, was there any way that you could write the formula that, hey, keep updating this column on the basis of some other column? There was no. So once you have put that, then that is static. I get a point. So the 3NF rule says that there should not be any interdependencies in the non-primary key columns. Got it? Non-primary key column should be independent of each other. Understood? So what have you learned about normalization forms? These are ratings given to how well or how well the database design is. Understood, everybody? Any questions? No questions, right?
Sir, what's the usage of 3NF?
What's the uses of?
What is the usage of 3NF?
अरे अभी तो देखा ना, that it reduce the redundancy by not having a column which has interdependency.
Okay, sir.
Okay, there is another quiz that has come from the class. The difference between MS Access, Microsoft Access, and SQL. Okay, all right. What is the difference, guys?
The image server and
MSSQL manually we can do the queries, but in SQL we have to write some queries.
What is the difference between MySQL and SQL? What is the difference between Google SQL database that we worked with and SQL?
Google SQL is a cloud.
And what is SQL? What is SQL? What is English? What is English? You guys are English honest students. What is English?
Yes.
It's a language. Does any company own that language? Do you pay England some royalty for speaking English? I mean, they can ask, but we don't pay. It's a language, right? Similarly, SQL or SQL is a language. Please understand, it's not really owned by any company. Does it make sense? Yes, IBM researchers had created it, right? I wouldn't really say invented because they created it. And then they made it open source, meaning free for anybody to use. So SQL is a language, database language, which is supported by all the database management systems, all the relational structured database management system. Microsoft Access, Microsoft SQL Server, Oracle, Oracle's MySQL, IBM DB2, PostgreSQL. These are all database management systems which support SQL. Did you understand this? इस तरह का आंसर मत देना कि MS Access में हम रिपोर्ट क्रिएट कर सकते हैं, यूजर इंटरफेस से कुछ कर सकते हैं, SQL में नहीं करते. अरे SQL is a language. The reason why we are focusing on learning SQL and not focusing on learning one particular DBMS is because I don't know which DBMS you will start working with once you start working with a company. I get a point, but SQL will remain SQL. The language remains same. Syntax may vary a little bit here and there. For example, when we wrote a few things in Google SQL, I mean Google BigQuery, right? I mean Google SQL is built on MySQL, by the way. So that is why the syntax of Google SQL and our MySQL SQL are they exactly the same. Mostly the same. But yeah, I mean it's like being able to speak English in Australia and being able to speak English in England. It's English ultimately. Yes, there can be some vocabulary. Dialect may change a little bit here and there. Okay.
Sir, hello. Hello, sir.
हाँ, hello.
हाँ सर, एक्चुअली वो जिसके पहले वाला जो ये था PDF था, दिखा रहे थे आप टेबल में, वो एक बार दिखाएंगे? वेट, खुला हुआ टेबल्स. सर एक चीज मुझे मतलब ठीक से समझ नहीं आया, यूनिट प्राइस को मतलब वो कॉलम मतलब क्यों ये हो गया, वो मतलब समझ नहीं आया ठीक से. मैंने यहाँ पर किया था तो वहां पर समझाया गया था कि मतलब आईडी फेच नहीं कर पा रहा है, इसीलिए वो टेबल ये हो जा रहा है, मतलब वहां पे ऐड हो जा रहा है कि मतलब टीचर्स को ऐड करने के लिए मुझे सब्जेक्ट आईडी से वो फेच कर सकते हैं.
क्या
तो
बोल रहे हैं हम कि are you asking why unit price should not be there?
Yes, sir.
The reason why unit price should not be there is it depends upon product ID, and product ID can have repeated values here, and every time product ID will repeat, unit price will also repeat, adding to redundancy.
Achha. That's why.
I get a point. Understood, everybody? Each non-primary की columns will be included in that primary, not just part and this. हाँ, ठीक है. अच्छा, ये तो हो गया. Sorry. What is ERD and what purpose does it serve? What is ERD? Entity relationship diagram, which essentially means, if you remember yesterday, we said we want to divide the database into 3 tables. And then we had identified that, okay, customer is related to loans and loans is related to employees, but employees not related to customers, right? Now, the only thing that we had not identified yesterday was where should the foreign key be placed. That depends upon the type of relationship that exists between the tables. Between employee table and the loans table, what is the type of relationship? One employee can review how many loans? Many loans. So from employee to loans, it is one to many. Then ask the same question other way. One loan can have
Only one
one
employee,
right?
1 to 1.
So if it is, so remove this, whichever one is more is what you take. So then the net relationship is one to many between employee and loans. Does it make sense? One employee can review several loans, or many loans can be reviewed by a single employee. It's the same thing, right? In a one-to-many relationship, we put the foreign key in the many side to minimize redundancy. In a one-to-many relationship, we put the foreign key in the many side. Now here, imagine this employee ID, E1, E1 again, E2, E1 again. That's fine. E1 is, let's say, Divya Singh. I get a point. It can have repetition, but the repetition is restricted to only one column. Is that making sense, everybody? Clear? In a one-to-many relationship, the foreign key goes in the many side. In a many-to-many relationship, we just discussed that the foreign key goes where? In a third table. Imagine now, what is the type of relation between customer and loans? One customer can have many loans, and one loan can be applied by multiple customers. You and your friend can apply jointly, or you and your husband can apply jointly for a house loan. You and your parents can apply for a loan together. Do you understand? So you have co-applicants on loans. So one loan can have many customers, and one customer can have many loans. So if it is one to many from both the sides, then what is the net relationship? Many to many. And many to many, what do? We create a third table. So let's call it as cust ID, and loan ID will come over here. Let's call it as customer loans. Understood, everybody? Cust ID, loan ID. Clear, guys? Give me one moment, guys. Hello? Okay.
2 सेकंड में वापस चिल्लाऊंगा मैगी मिर्चा दीजिए.
Huh? Okay. So we'll create a third table: customer and loans, cust ID, loan ID. So cust ID and loan ID will be there at least in this third table. Got it? And then, of course, there is a relationship between cust ID and the customer table. And sorry, customer loans and the customer table, and customer loans and the loans table, because there are common columns, right? Got it? So this structure, this design that we have in front of us, right? This design that we have in front of us, which is customer, loans, and employees, right? With all these columns and these relationships, is called as entity relationship diagram, or ERD. In other words, it's also called as database schema, schematic structure, or database design, or schema design. Okay, different people like to call it differently, but it's the design of your database. And when we say design of the database, we don't care about the data. It doesn't have to have data in it. The design basically just means design. It's like design of a house doesn't mean that you are also there. Design of the house is just a house which is empty. It's just how would the house look like. Does it make sense? And what purpose does it serve in database design? The reason why we design it before we create it is just like any other design process, right? Why do you design a house before you actually start creating it? So that you know what to design. So ER diagram also helps you to know where all you may face problem, because once you have ERD, then you can pass the ER diagram or database design from that 1NF, 2NF, 3NF rules. I get a point. Now, how do you determine the relationship between entities in ERD? How? How did we determine that relationship? So we took one row from customer and we asked how many loans can one customer apply? We said many. Then we took one loan from the loans and then we asked how many customers can it have? Many. So that's how we determine the relationship. If it is one to many from both sides, it will be many to many. If it is one to one, many from one side and one to one from the other side, then it is one to many. Is that making sense? And if it is one to one from both the sides, then it will be one to one relationship. One to one relationships are very rare, because normally if in a one to one relationship, we end up merging them. I'll give you an example. Citizenship table, passport table. Citizenship table and passport table. One citizen can have, meaning let's say instead of citizenship, let's call it as Aadhaar table. One citizen can have one Aadhaar, and one Aadhaar holder can have one passport, unless you're doing a fraud, right? That's the reason why they have linked everything. That's the reason why they're linking Aadhaar with PAN, Aadhaar with driving license, Aadhaar with passport. Because in India, I know so many people who had so many PANs. I can find so many PANs. Every business had a different PAN. Big people. I get a point. So the moment it is linked with Aadhaar, then how do you have more? That entire business goes. There were so many CAs whose main business was to facilitate this business of having multiple PANs.
Banks we have faced this started after demonetization. We have seen one people bearing 2-3 PAN cards. We have seen this.
And the government also was very lenient. अरे आपका पुराना पान खो गया है, कोई दूसरा पान देंगे आप. जो ब्रोकर रहते थे ना, बोलते थे सर दूसरा पान आ जाएगा, चिंता मत कीजिए. So they would give another PAN very, very easily.
Right, difference in the spelling of the
Names. So instead of correcting the old PAN, they'll say, sir, let's give another PAN. So correcting में बहुत time लगेगा, 6 महीना लगेगा, नया PAN 1 महीना में आएगा. That's how it was so simple to commit fraud in India, financial frauds, right? But with all that Aadhaar linking and with all that it has become almost impossible. And that happened within like a few years only. Do you understand? So you don't know the shadow economy, which was parallel economy. So if India's GDP is X, then it was actually 2 or maybe 2.5x. And it's not easy that how that business went away with 2 things, 3 things, in fact, Aadhaar, GST and demonetization. 3 things. In Calcutta, there must be at least 1,500 to 2,000 CAs whose business was only this. And the government came so heavily on these CAs, you'd be surprised. Bada Bazaar mein, एक छोटे office में. So Bada Bazaar is a small area, I mean not a small area, actually big area, but very congested in Calcutta. Okay, every office, there were so many offices which were like 200 square foot office, but had 2,000 companies registered to that office by 20,000 different people. I get a point. So all of that has gone overnight. Not overnight, but over a 1 or 2 year period. So anyway, so the reason why one-to-one relationships are rare, because the moment you have one-to-one relationship, ultimately you will end up merging them. So what the government will eventually do is, which most of the Western governments do, is that you don't have so many IDs. Like in the US, we had only one ID, SSN. We didn't have a tax ID separately. Okay, one more ID we had, a driving license number. That was separate, but that too was driven by SSN. But everything was driven by SSN. Your bank accounts were driven by SSN. Everything was driven by SSN. So there was only one ID. Everything was linked to that. So ultimately what happens is when you have a one-to-one related table, you end up merging them. That's the reason why we see one-to-one rarely. Okay, because tomorrow if government says that you don't need a separate PAN card, why do you need a separate PAN card? You have Aadhaar. You don't need a ration card number. You don't need so many IDs that we all carry proudly in India, right? You don't need so many IDs. You need one ID. That's it. Right? They will end up merging the tables. So one-to-one relationships, related tables, typically end up getting merged. Is that making sense? That's the reason why they're rare. The reason why I give you so much gyan about these relationship types is because when you go into interviews, some interviews, not all, some interviews will go into the details of database design, because that shows whether you know how to work in an efficient data governed process. One inefficient way would be that don't worry about size of the table, relationship of the table, just keep creating tables as you go. But that would lead to a lot of redundancy, inconsistency, incorrectness in the data. Right? That's the reason why a lot of companies, a lot of recruiters would want to understand whether you understand NFs, normalization forms. Not necessarily that you will be creating them as part of the role, but you will be part of that team which would talk about these things very frequently. Okay, now coming back here, can you give an example of one-to-many relationship? We have seen that. What role do foreign primary key play? So it becomes a unique identifier. Foreign keys are
Unique data
to create relationships. Is it important to minimize redundancy? To improve database efficiency, you said. Okay. Well, redundancy, to reduce redundancy. Redundancy is the mother of so many problems: wastage, space wastage, data integrity issues, data inconsistency issues, right? This question, how can normalization impact the performance and integrity of your database? It reduces the space, perfect, no problem. Integrity wise, it improves the data integrity. Performance wise, although it may have a negative impact as well, because you may end up dividing the database into so many different tables. However, it may also have a positive impact because it would reduce redundancy space requirement quite a bit. I get a point. So if you're working on a very small amount of data and you've divided into multiple tables, then it may have a negative impact. But if you are working in a scenario which has a lot of data in it, then a lot of interrelated categories, then it would have a better impact on the performance. So generally, normalization has positive impact. That's the reason why most of the time we go ahead with normalization. Got it? Okay. Good. ChatGPT did a good job. Queries.
I have seen if I want to drop down into a single column, suppose if I want to see there are a lot of details of customer. Now I want to see a specific detail, and when I put that into my system, that give a error message because they have created the formula like that only, and you have to put the formula or the command, and you just need to put the customer ID. That's it, and things will be in place. But if I have to go and modify that, the system don't allow. So whether
Modify what?
Suppose there's a customer ID and there's a scheme, some scheme.
Customer ID.
Yeah, customer ID and there's some scheme. So there are different schemes. So if I put customer ID, scheme name, where scheme name is equal to this, there are different scheme name under that ID. The system will go and show me the error message. That means they have locked it somewhere. So
no, what if that customer doesn't have that scheme?
It will not show now. It will show no records. But suppose if under this customer ID there are certain schemes, and I just want to see that scheme, and I want to see whether it is rejected or accepted. I cannot see that. I have to
you can't see that.
Yes.
Maybe because the scheme table is separate and you don't have access to the scheme table.
Okay.
That's what we discussed yesterday.
So I have the entire table with me. If I go and put select only, I can see the entire table. But in any case, I cannot give a filtration to that command. The way we do here. The way we do.
You have the scheme column in the table.
Yes.
And you can do select star and you can see that column.
Yes. But if I go and see the specific table, I cannot do that.
Specific table or what?
Specific table means specific thing. Column.
Really, I'll have to see. There should not be any
I'll
reason.
show you
Because when you are able to see all the columns, and then when you are writing it, maybe the format is separate. Maybe the format is not.
The format is this only select from where.
No, format of the scheme. How you're giving, because there is no reason why you'll not be able to see it otherwise. Okay. What we want to do is, we have these 4 tables. We have created it. This is our ER diagram, but we have right now designed it on paper. Right now, what we will do is we will create this design, this database design, in MySQL. I get one guess. Clear? So let's open MySQL database, and I'm going to upload some commands, okay, which will help you to create the database. And don't try to memorize the command. If it happens naturally, great. Otherwise, don't try to memorize the command. Go to the classroom and download this file. Download this file. It's a .sql file, so you have to download it. It says create loans DB on DDL using DDL statement, data definition language statements. Okay. Go ahead and download this. And in the meantime, when you're downloading it, let me give you a quick overview of what DDL, DML, and DCL statements are. DDL is data definition language statement. DML is data manipulation language statements. And DCL is database control language statements. These are all types of SQL commands. Okay. We have already seen quite a few of these SQL commands. We have seen create, we have seen select, we have seen insert, we have seen update, we have seen delete, we have seen drop. We have seen a lot of these commands, but they are divided into multiple sections or multiple types. SQL is divided into DDL, DML, DCL, and there is one more, called as TCL, transaction control language statement. Got it? DDL is data definition language statement. DML is data manipulation language statement. And this is control language statement. Definition or design, you may also remember it as design language statement, which has 4 commands mainly: create, alter, drop, and truncate. Create we've already seen. We'll see some alter statements. We have seen some drop as well. We'll see truncate as well quite soon. Manipulate, we have seen all of them. Manipulate allows you to manipulate the data. This allows you, these statements allow you to manipulate, to change and alter the design. When I say design, meaning the table columns, the table properties, or the database. I mean, how many tables you want, which table is related to which table. So all that, the design related things, not the data related things, just the design related things are done using DDL statements. But data related things, when you want to insert new data, then insert statement. When you want to update existing data, then update statement. When you want to delete existing data, then delete statement. And when you want to query the data, then it is select statement. Is that making sense? So these are all these statements are to do with data, and these statements are to do with access rights. Who has what level of access? Who does not have access to which tables, which columns? So this is done by the database administrator. So that is the reason why we don't talk about them. Okay. Now, let's talk about the DDL statement that I've just uploaded, which will help you to create the loans database. Okay. Now, who would like to share the screen, who has not had an opportunity to share the screen? Let's see. Ravital Agar Warkar. You want to share the screen?
Yes, sir.
All right. Haji.
So is it visible?
Yeah. News. Okay. Can you zoom, please, Ravital?
Yes, sir.
By the way, load that file that you just downloaded, no?
Yes.
Zoom also. Zoom.
Control plus is not working.
Not control plus. Control and scroll up, scroll down with your mouse.
Yes.
Now scroll down, guys. Okay, here, right over here. So what are the tasks that we'll perform? We want to create the database, a new database called as loans_db. It's going to be a new database. Don't replace the existing one. Okay, so we'll have to give a new something different. Loan_db, let's say. Create the tables in the database. Which tables will we create? The 4 tables that we saw, which are customer, loans, employees, and customer loans, that 4th table that we had. Then we'll create the columns in the table. We'll assign data types to each column. Scroll down, Navita, and then we will create constraints like primary key, foreign key, unique, not null, check. We'll create those things as well, and then we'll create the relationship constraint by a foreign key. Constraints meaning restriction. When we say a column is a primary key, then we are restricting that column to be unique and to be mandatory, not null. I get a point. That is the reason why it is called as a constraint. Understood? Now come down. All these 3rd and 4th step will do. So look at the command. First command is to drop, but you don't have the database yet. So what will you drop? So we'll just go to line number 31. Create database loan_db_new. So run it. Now when she runs it, she will get that loan_db_new on the left hand side, and then we will use it. So it becomes the default one, right? Then what is the next thing that we'll do? We'll create the tables in the database. We've created the database. We have made it default as well. Now we'll create the tables. Now when creating the tables, remember one very important thing. Create the tables which are on the one side first. See, the one side tables are also called as parent tables. One parent, multiple child. One to many, one parent, many child. So one side table should be created first. First create the tables on the one side. You know the reason for that? Because when we create the child table, the table which is on the many side, then the foreign key is there. And that foreign key has to refer to the primary key of the one side table. Do you understand what I'm trying to say? So there is a dependent column here. Does it make sense? That depends upon the one side. Is that making sense, everybody? So that is the reason why you need to have the parent first, so that you can create the dependency later. So that is the reason why in our database, if you remember, customer table is on the one side, employees table is on the one side. So those 2 tables have to be created first. Let's go and create them. Come down. So if you look at line number 49 onwards, it says create table customers, cust ID, integer, and primary key. This is constraint. This is a constraint. Primary key, integer, is data type. Customer name, char 100. Email, varchar 50. DOB, date, not null. DOB, date, not null. Basically means that the DOB column cannot be left null. Cannot have blank values. It is a mandatory column, right? Now, varchar and char are both text data type, string data type, meaning they can contain alphabets, special characters, spaces, also numbers. Okay. The difference between varchar and char, you will research and tell me in the next class. I will ask you as a quiz. Okay. And it's a very important question. I know it's given, but people will not understand static memory.
There is a difference in the
dynamic
storage.
memory. If you
The
can
difference
understand
in
that,
storage.
if you can understand just by this hint, then you don't really need me for most of the classes. Yeah, so do a research between char and varchar. One is static memory allocation, one is dynamic memory allocation. Just do a little bit of research. But for you to understand, both are string, both are char. Okay. Having said that, primary key basically means it is a not null column as well as it is a unique column. Okay, it has two more constraints. The moment you assign primary key constraint to a column, it has two more constraints to it: not null and unique. Go ahead and create this. And refresh and see. Got it? Now, describe customers will actually just give you a something like this. Go ahead and describe it. It'll give you the properties of the table. Upar gaya. These are the 4 fields. These are the data types. And this is telling you whether null values are allowed or not allowed. First one is primary key, cannot have null values. Last one we said not null, so cannot have null values. This basically means PRI means primary key. UNI basically means unique. Got it? All right. The same thing here, what we are seeing. All right. Now, close this result grid. Here in line number 58, 59, it says drop the primary key. Alter table customers, drop primary key. Alter statement helps you to alter the design of the table. Update statement helps you to update the existing data. Alter helps you to update alter the design, meaning maybe add a new column, drop an existing column, add a new constraint, drop a constraint. Essentially, these are the 4 things we do with alter. Alter table customer, drop primary key will drop the primary key column or just the primary key constraint. Will it drop the primary key constraint or will it drop the primary key column, which is customer ID? It'll only drop the fact that cust ID is primary key. That means it will drop that fact that it is going to be not null and it's going to be unique. But it will not drop that column. Remember, if you want to drop the column, then the statement that you have to write was alter table customers, drop column cust ID. But then it'll give you an error also because it'll say that cust ID is a primary key column and it cannot be dropped. If you want to drop the primary key column, there are 2 options: either drop the entire table or first remove the constraint, then drop the column. You understand? Primary key column has a lot of special powers to it. All right. Now, in order to add the constraint, if you have dropped it, alter table customers, add constraint, primary key, and in the bracket you will write cust ID, which basically means you're adding primary key constraint to which column of this table? Cust ID. Got it? Again, as I said, don't try to memorize the command. Just read, understand what's going on. So if you have to alter, change the command, you can change it. Come down. Let's create another table. Now look at this table here. This table will create employee ID with emp ID as primary key and email column as not null, and salary column's default value will be 0. What does it mean? That as even if you don't enter any value under the salary column, the default value will be 0. Got it? Clear, guys? Now, Now what? Let's create the loans table. We have created the customer table and the employees table. Now we'll create the loans table. In the loans table, if you notice here, we are going to refer to the employees table employee ID. That means we're creating a column here, employee ID, and we are making that column foreign key. We created a column called as employee ID. In the loans table, employee ID, employee table, the loans table doesn't have a property called as employee ID, but we created it. Why? Because we want to create a relationship between loans table and the employee ID. An employee ID has to be there in the loans table. Why? Because it is a many side as per the design that we have already created, ERD that we have already created. So emp ID in this table will be the foreign key, which will refer to employees table emp ID. Now, what is this thing here? Constraint L underscore FK1 foreign key emp ID references employees table. This L underscore FK1 can be Tommy, your dog. Doesn't matter. Can be anything. It's a reference given to the fact that this is foreign key. Similarly, this L underscore PK is also a reference given to the fact that loan ID is primary key. So it's a reference given to the constraint. Reference given to the constraint. Is that making sense? Guys get my point. Understood? This is a reference or a name given to the fact that emp ID is foreign key. Every constraint that we create can be given a name, because as we saw earlier, when we dropped the primary key constraint, we were just dropping the constraint. We were not dropping the column. So constraint is one part and the actual column is another part. I get what I'm trying to say. It's like saying that you go to Queen of England, she really likes you, she gives you a title that you are sir. But now let's say you commit a fraud, you write something bad about her, she says, no, I'm taking your title back. It doesn't mean that she's killing you. You understand what I'm trying to say? You will remain. So what I'm trying to say is that title or the constraint and the column are two separate things. Column is custom, let's say employee ID, emp ID. And the fact that it is foreign key, that fact is given a name L underscore FK1, which is constraint. Do you understand? So if you scroll down, so first create this table. Go ahead and create this table. If you scroll down, you notice here we are doing some alteration to the table and we're dropping what? The foreign key constraint. But it doesn't mean that we are dropping the foreign key column. We're just dropping the fact that emp ID is foreign key. And then in the very next line, we are adding it back. Clear, guys? Any questions on this? Come down.
Sir, I had a question here.
Tell me.
Sir, is it necessary that foreign key in a table should definitely be the primary key in another table to found may form a relationship?
Can you repeat that?
To form a relationship between two table, is it necessarily important to suppose in employee ID, we are making employee ID in foreign key in a table and its primary key in another table. So is it necessary to make particular one column as foreign key in one table and a primary key in another table to relate the two tables?
Yes, the foreign key should be related to the primary key in the other side of the relationship. That is a much
Okay.
better design.
Okay.
Okay. Got it? You see, you don't, basically what he's saying is that, let's say instead of emp ID here, suppose if we make employee name refer to the employee name of the employee table, will that be a good thing? Now let's say employee name Ramesh Singh, one more Ramesh Singh, one more Ramesh Singh. Here also you write Ramesh, the system will allow, no problem. But the system will say, I mean, you will get confused in the report itself. When you're doing a join between them, create a report, you'll be like, oh, which Ramesh is which? I get what I'm trying to say. Clear? That's the reason why we say it is a much better design to make the foreign, it's like an unwritten rule that foreign key should be related to the primary key in the other side. Understood?
Sir, hello. Actually, I have a doubt in constraint for foreign key. Na? If you write add constraint, then constraint for foreign key and reference after employee ID, the reference will be for table. Means adding to the employee ID directly connect to the employee. Na? This means.
Basically, this employee ID is from the loans table. It's a column of the loan table. We are relating it to the employee ID of the employees table.
Okay. Okay.
This is a common column between them, right? So you have to tell that this column is related to this column in this table. Just because the two columns have same spellings does not mean that, you know, they're related. I get a point what I'm trying to say. Now come down. So just telling you, how to add and how to. So all the four tables are there now, Ravital? Four tables, no?
Sir, not 4, only 3.
Come down, there must be one more table. Oh yeah,
Loan
customer loans is there.
status.
Come down.
Yes,
Here.
customer loans.
Now here in the customer loans table, by the way, how many constraints are there? There are three constraints. One is primary key and there are two foreign keys. Why? The cust ID will refer to the cust ID of the customer's table and the loan ID will refer to the loan ID of the loans table. Did you all understand this? Why we have three constraints here? Stop me if you have not understood. I will explain. No problem. Wow. तो वेट कर रहा था मेरे बोलने का. नेक्स्ट टाइम वेट नहीं करने का, बोलने का नहीं समझ आया सर, क्या प्रॉब्लम है यार? ठीक है ना? So I'll explain this again. You remember the reason why we created the loans table is because there was a many domain relation between customer and loans, and we created a third table. In the third table, if you remember, we had put cust ID and loan ID. Cust ID depended upon the customer's table cust ID, which also has cust ID, other columns, customer name, POB, gender, and whatever. And the loans table has related to loan ID, amount of the loan, loan status, but this is loans table, right? Again, what? So this column of this customer loans table relate to the customer's table's cust ID, and this column relates to the loans table loan ID. That's what we are doing. C1 FK1, which can be anything, or CL FK1, cust ID refers to the customer's cust ID, and loan ID refers to the loan's loan ID. Understood? Let's run it.
Sir, sorry to interrupt once more. Hello.
हाँ बोलिए.
हाँ, yes sir. हाँ. Sir, actually, just a minute. Sir, in employee table, we are making cust ID as primary key, and in loans table, we are making the cust ID as foreign key. Uh, Sir, if we'll make the cust ID as primary key in both the tables, so will it work?
No.
Okay. So in order to link the both table, we have to put one primary key and the same to another table as foreign key. Got
Yeah.
it, sir.
Got it, guys?
Yes.
Clear? Yeah. Okay. Now we have 4 tables. Got it? If you want to visually see this ER diagram, that also we can do. How? Go to database on top. Go to reverse engineer. Then select the same connection select the connection. Yeah. And then the connection with which you've been connecting with the database. And then press next. You'll connect to the database, press next. Select the database, which is, I think, row underscore db underscore new. Next. Finish. Check the results. Next. Import. It'll place the imported objects on a diagram. 4 tables and 4 objects selected, right? Next. Done. Yeah, done. Yeah. Close it. Scroll down. Look at these 4 tables. Now you can see them visually. Bring this over here. Yeah. Do you see? Employees table is related to the loans table. Customer table is related to the customer loans table, and loans table is related to the customer loans table. Understood, everybody? Clear? Understood?
Yes, sir. It's connected to foreign key.
Got it? And you can export it. Go to File. Export.
So this one.
As single PDF. Give it a name. It'll actually create a PDF file where it will store the created diagram. What happened? It's not able to do it? Okay. Got it, everybody? Okay, now let's go back to the scripts. Close this tab.
I cannot see the option of closing.
On the top here. Got it? Close kernel. The
Sir,
tab.
the Zoom tab is open, so I cannot.
You okay? Anyway,
I'm
click
unable.
click here. No.
Arrange?
No, on top, yeah.
Okay.
Now, what we will do a few more things here. Okay. Copy the data from one table to another existing table. Both these tables have same schema. Create a new table using the data from an existing table. Now there is no data. Come down. Let's see if there is some command given. Okay. Go to some other database. Go to some other database. The database which has some data in them. I think your loans DB has some data in it, right? So use the
Yes.
loans DB. What I want to show you here is that you can actually copy a table, including its content, that means the data, into a new table or into another table which has the same structure, same number of columns. I get a point. So copy the data from one table to another existing table. But here, both these tables should have same schema, meaning same number of columns, same data types, and so on and so forth. For example, here we are creating a new table called as customers underscore 3. If you go to in the loans table, you don't have customer table.
So there are many. I could use this one.
नहीं उसमें तो बहुत सारे हैं उसमें भी बहुत सारे हैं कॉलम्स चलो loans use करेंगे. How many loans has 3 columns in it, right? So let's create a table called as loans underscore 2. Ravital,
Yes.
let's create a table called as loans underscore 2.
In
line
like
number
this?
No, in line number 1, 2, 3, it says create table. Instead of customers underscore 3, let's create loans underscore 2 or something. Basically, we'll create a replica of the loans table, loans underscore 2, and it should have loan underscore ID integer, loan amount integer, cust ID integer. Loan amount should be integer. And cust ID should be integer. It doesn't matter. The spellings of the columns do not matter. The data types would matter.
Yes.
Now, select and create. Verify. Yeah, created. Now what we will do is that in the loans table, you have some data. So let's write select star from loans table. Select star from loans in line number 1 to 8. Loans.
The one that we made now?
That of course doesn't have any data in it.
Loans, okay.
So it has these 4 rows, right? What we will do is that we will take this data and copy this data to the loans underscore 2. It's very easy. You have written select star from loans, right? Now instead of star, write specific columns so that we know which column we are migrating. Right? Select loan underscore ID, comma loan underscore amount, comma cust ID. dot comma cust id from
Yes.
always give a line space, okay, between two queries. Now, on top of this query, how do we insert data into a table? Insert statement.
Insert into.
On top of this query, write insert into. On top of this query, write insert into. Top of this query. Top का मतलब नीचे नहीं होता. Top. Insert into. Which table? Loans underscore 2. And then in the bracket, mention the columns. The same sequence of columns. But remember, the column names are different for loans 2. It is loan ID, loan amount, loan AMT, cust ID. Close it, right? Insert into loans underscore 2, loan ID, comma, loan amount, comma, cust ID, and normally they write values. But here, we already are getting the values from this select statement. So just put this select statement here without writing the semicolon. So the entire statement becomes one statement from here till the end of SQL here. This is one statement now. Insert into loans underscore 2, loan ID, loan amount, cust ID, from which values? From the values that we get from this red query. Go ahead and run this entire statement. Now it's not going to show you anything because it's an insert statement. If you want to see the data of the loans 2 table, then you would do select star from loans 2. Got it? So we are successfully able to migrate the data from or copy the data from one table to another. Very simple. But here we have to create that table first, right? Now, if you want to create a new table using the structure which is already there in the existing table, and at the same time copy it also. Now, let's do select star from loans. Yeah, we have this query. On top of this query, write create table loans underscore 3. Create table loans underscore 3. Right? And no semicolon. Remove the semicolon and just put that select star right next to it. So, remove this line here. That's it. Magic. Create table, name the table, select star from loans. So what it will do is that it will first run that select statement, get all the columns as well as all the data, and then create the table and then also insert the data also. Do it. Verify. Run a select star from loans 3. अरे कॉपी करके डाल. Did you understand this? So copying the data from one table to another table is not rocket science. What if we want to create one more table called as loans underscore 4? This time, I want to create a blank table, but using the columns which are given in the loans table. Earlier, we had to use a create statement to do it. So any suggestion, how do we just create a copy of the structure, I mean a copy of the loans table? How do we do that? This statement created the table along with the data. Now go to this statement again, or maybe copy this statement, paste it somewhere down. Yeah. Now create table loans underscore 4. कोई तो सोच रहा होगा कैसे करेंगे? Did you understand what we want to do? We want to create loans 4, but without the data, using the design of the loans table. I don't want the data to be imported in that process.
Sir, we can give a false where condition in the select.
Good job. Did you understand what Sanmitra is saying? He's saying, give a where condition which is impossible to meet. False where condition. He's saying, right where Paris is equal to New York. Meaning any condition which is not possible, right? Loan ID is equal to 999 or anything which is not possible. So in this line number 132, after loans, write a where statement where India is equals to Pakistan.
Yeah, if 0 is greater than 1.
अरे अरे मजाक कर रहा हूँ तो आप सही में लिखने लग गए. Write something like loan ID is equals to 1000. We know that loan ID is not there, or loan ID is null. You can also write is null. Right, now run it. Is it loan ID or what is it the name? What is the name of the column? In the
loan
loans
underscore
table,
ID.
it's loan underscore ID.
Yes.
Got it, everybody? Clear? Now verify loans 4. Loans 4. Got it, guys? Okay. Thank you, everybody. Good to have you. Alvida, enjoy. Before you go, some gifts from my side. India is playing with South Africa. Enjoy the game with some assignments. Two assignments that I'm going to give to you. For your favorite social media platform, whether it is LinkedIn, Insta, Snapchat, whichever one. Facebook तो कोई use करता नहीं है आजकल. Anybody logs into Facebook at all? Like, huh? Ex girlfriend के लिए actually. नहीं, पुरानी वाली तो Insta में डालेगी नहीं ना, इसीलिए वो है, और कोई reason नहीं है. Please create ERD for that social media platform that you like. If you want to do some Googling, research, ChatGPT, do that. But figure out how the data will flow, what would be the major categories of information, right? And then create the database design. The deck that I've shared with you already, or the tutorial that I've shared with you already, has a few steps, recommended steps, which is what we have also discussed. database design process. Determine the purpose. Find and organize information basically means how many categories are there. For example, student, customer, loans, employees. Divide information into tables. Turn information items into columns. Specify primary key. Specify relationships. See, refine your design is fine. It's fine, but basically apply the normalization rule and see how well the design is. These are the steps that we roughly follow. It's not a perfect science, okay? But these are the rough steps that we normally follow when we create a database design, right? So do it. Once you have done it, right, then create it in MySQL and submit the screenshot of your ER diagram. You know how to put the ER diagram now, right? Got it, guys? That is first.
प्रैक्टिकल कंपनी बेस्ड वर्क हमेशा लिखना पड़ता है हमेशा जो एम्प्लॉयज होते हैं वो क्या ये कमांड्स लिखते हैं
Sir, hello.
ये लोग
Hello.
One question he's asking is that in the companies, do employees even write the commands or they just chat GPT? Now the point is, in this world, no sane developer will ever write complete commands. But you see, it is very difficult to keep going to chat GPT again and again and again and again, or keep Googling. And plus, second thing is, a lot of times you will work on legacy lines of codes which are written by somebody else. And you are supposed to modify that. Now, if you don't understand yourself, there are two problems. One, you will not clear the interview. Second, you will not, once let's say you clear the interview as well, once you start working, you will not understand sala is code mein ho kya raha hai. You understand what I'm trying to say? So you have to understand how to modify the code. In order to be able to understand how to modify the code, first you have to understand the fundamental of code, which is what you're doing right now. That is the reason why I keep telling you, don't try to memorize the commands. The idea is that our professor would never say so. The reason why our professors would never say so, because we learned SQL and all before Google came. Right? Back then, it used to be a memory test. Who remembers the syntax the best? I get a point. But now you don't really have to remember the syntax. I can tell you with full guarantee that nobody needs to remember the syntax properly. If it happens naturally, great. Doesn't happen, it's also fine. But you should understand what's going on. Why the syntax is written the way it is written. I get a point. You should, if required, you should be able to modify that. And let's say even if you take that copy, put it into ChatGPT say, no, this is bad, please do this. You should understand who bol kya raha hai. I understand what I'm trying to say. Right?
Hello, sir.
Yeah, sir.
Sir, actually, in last code, you just copy from loan, create loan underscore 4, and there will be little bit doubt that where is loan ID is equal to null. Actually, loan ID underscore ID is already mentioned in loans table, or that's why you fetch the data. Like पहले से वो लोन्स टेबल में था वो टेबल, इसलिए वो फेच कर पा रहा है
हाँ
उसको।
जी, हाँ जी, यस।
अच्छा अच्छा, मतलब उसी नाम से होगा ना, मतलब लोन
हाँ,
अंडरस्कोर। अच्छा अच्छा, नहीं तो नहीं कर पाएगा सर।
कैसे करेगा?
हाँ
So I've given you two very easy assignments to work upon. Um, there was this assignment which was this. Okay, this we did, right? The age in following format and all of that. We also did the box office one, right? We did also this. कुछ तो अलग हुआ. Have I given you guys credit card database? You all have imported it, right?
Yes, sir.
Okay, I'm giving you one more case. Okay. This is on women IPL. ठीक है, कुछ बचा नहीं है लगता देने के लिए.
ऑलरेडी डन इन द क्वेरी।
जाओ, enjoy.
Thank you, sir.
थैंक यू सर।